Hi guys, welcome back. In this video, I'll be explaining the sum of a geometric progression to infinity. In the last video, I explained how you can find the sum of a GP, and I gave you two formulas. So one is when your R is greater than 1 and when your R is what? Is less than 1. Given that your A is the first term, your R is the common ratio, and your N is what? And your N is number of terms. Sorry, this is first term. And your N is number of terms. I said your sum is A into 1 minus R is per N divided by 1 minus R. When what? When R is less than 1. And it can also be, you can use this formula as well. So when R is greater than 1. So what if, this series, that is this sum works for this kind of sequence. When you have A R square up to the what? Up to the nth term, which is R raised per minus 1. What if your sum is to infinity? What is the sum of the GP is to infinity? That is when you have this type of sequence AR squared to infinity, and this term is not there. This nth term, that is, it is definite. When we say infinity, infinity means what? Boundedness. So, or you can still say it is endless, maybe a larger number than any other number. You understand now? So, and that's why when you say an example of infinity is, it's a set of natural number. It doesn't end. When you start counting natural number from now up till 100 years to come, you will still be there because it doesn't have what? An end. So that's what sum to infinity. So how do you now find this sum? It is not difficult to do. Let me quickly derive a formula for you. You can get this formula from what I've even informed you now. For example, from the formula we obtained already, recall that your Sn is what? 1 A into 1 minus R is per N divided by 1 minus R. You understand now? If I were you, I can say, if I open the bracket, I can have A minus AR is per N divided by 1 minus R. You understand now? And it's just like when you have 1 minus 2 divided by 3. I can split it to be 1 minus 3 minus 2 divided by 3. Is that not so? So meaning I can have that A over 1 minus R minus AR is per N divided by 1 minus R. Now, we want to find the sum to infinity. S infinity, this is for S raised per N. That is, whenever I see N here, I put my infinity. So then I'm going to have 1 minus A divided by 1 minus R minus A R raised per infinity divided by 1 minus R. Okay, now, let's say my common ratio is like it's like 2. If you have your common ratio to be 2, 2 raised per infinity will give me 0. Do you know that? That's from the concept of limit. Let me explain to you. I said infinity is like a very big number. You understand now? So infinity is like a very big number. So let's say when your end is like let me give you an example, so like a concrete example, so that you understand what I'm trying to say in essence. So for example, so when I have this term 1 plus 1 over 3 plus 1 over 9 plus 1 over 27 plus dot dot dot. So A here is 1, right? And my R is 1 divided by 3. You understand now? So it means if you substitute it here, your S infinity will be 1 divided by 1 minus 1 over 3 minus A into 1 over 3. Okay, our A is 1, right? Multiply by 1 over 3, everything raised by infinity divided by what? 1 minus 1 over 3. Okay, now, this is what I was explaining the other time. It's just like when you have 1 divided by 3. This 1 divided by 3 is 0 point what? Eh? Anybody? So 1 divided by 3 will give you 0. When you have 1 divided by 3, that's 0.3333. You understand now? Okay, now when you now raise it to power of 2, let's say you have 1 divided by 3 squared. What is 1 divided by 3 squared? That is when you multiply it by 2, you have 0.0666. So what is like when you have 1 divided by 3, so maybe when your n is equal to 5, so 1 divided by 3 raised to power 5, you have 1 divided by 3 raised to power 5 will give you what? 0.004. You will see that as the number becomes larger, this raised to power 1, as number becomes larger, so your number approach what? Your number approach 0. You understand now? And if only when you take 1 divided by 3 raised to power 10, that will give you 0.000016. Now you understand now. So, okay, what if you now use 100? It will be approaching 0, it will become bigger. So, and we said infinity is like the largest number than any other number. It means when you take the limit as your r raised by infinity, so tends to what? Let me say as your n here, so as r raised by n tends to infinity, or you can just say as n tends to infinity, your r raised by n tends to 0. And if r raised by n tends to 0, then you are going to have that this term, that is r raised by n divided by 1 minus r, that will also tends to 0. So that's why all of these will be 0. I hope you understand now. So since I know that 1 divided by 3, everything raised by 5 is 0.004, and everything raised by 10 is what? So it's 0.000 something. It means when you now use the largest number, what you are going to have is what? 0. 0.0000000, which is 0. You understand now? So if this is 0, any number divided by 0 will also give you 0. That's why we say our S infinity here will now be 1 divided by, I think this is 2 divided by 3, which will give you 3 over 2. So in essence, so this guy, this is what we are doing before. So we have that our S infinity, that's will A divided by 1 minus R minus 0. Do you know how it is 0? Just say as n tends to infinity, then you have that your R raised power n tends to what? Tends to 0. You understand that? And your n here is infinity, so it means your S infinity is equal to 1 A divided by 1 minus R. And that's the formula you'll be using to calculate the sum to infinity of a number. Let me give you an example to back it up. Example. So given that the sum to infinity of a GP is 81. The sum to infinity is 81. If the first term of the series is 9, then we ask to find the common ratio. Determine the common ratio and the third term. So determine this common ratio and the third term. That is not difficult to do. So we already know our formula. Recall I obtained the formula. The sum to infinity is what? Your S infinity is A divided by 1 minus R. You understand now? So now the sum to infinity, your S infinity is 81, and your first term, which is A, is what? Is 9. So then if you substitute now, we have 81 is equal to A divided by 1 minus R. What is our R? That's what we are looking for. Okay, my A is 9. You understand now? Then I'm going to have 81 into 1 minus R is equal to 9. So 81 into 1 minus 9 is equal to 9. So then if that is cleared, if you substitute, then I'm going to have, or if you simplify further, I'm going to have 81 minus 81R is equal to 9. If you collect the like time, this will be 81 minus 9 is equal to 81R. What is 81 minus 9? 81 minus 9 will give me what? So I think that is 72 is equal to 81R, right? If you divide both sides by 81, then your R is going to be what? 81 divided by 72. And I think 9 can go here. How many 9 are you going to see in 9 in 81? I think, am I making any sense? Look up 81 minus 81R is equal to 9, right? Yeah, I'm correct. So then if you bring this guy here, okay, 81 now. Then we divide through by, no, we divide through by 81. Then your R should be 72 over 81, not 81 over 72. Sorry, my marker is behaving. So this guy is, let me just delete this. What is wrong? The marker has stopped working. So let us try it now. Let us try it now. Oh, that is strange. So, okay, now maybe I should be using my hand in interim because this guy is not working again. I don't know why. So your R will now be what? So your R is going to be 72 divided by, your R is going to be, that is strange. So sorry. So the marker is working back. So my R will now be what? My R is 72 divided by 81. And 9 is common. So how many 9 are you going to see in 72? That's 8 divided by 9. So it means your R is equal to 8 over 9. That's the first question. And what's the second question? The second question asks us to find what? The third term. So what is the third term of an AP, GP? So third term is T3, that's AR, everything squared. And we know that my first term is what? Our first term is 9. That's 9 multiplied by 8 divided by 9, everything squared. That is 9 times 65 divided by 81. 9 1 here, 9 1 here. That's 64 divided by 9. So which will give me 7 number 1 over 9. That's that. Let me give you another example. So I think this is also a jump question. So the sum of the first three terms of a GP, the sum of the first three terms of a GP is half its sum to what? Is half its sum to infinity. Is half its sum to infinity. Find the positive common ratio. Find the positive common ratio. Yeah, this is not difficult. The sum of the first three terms of a GP, that is A plus AR squared, right, is equal to half its sum to infinity. Is equal to half its sum to H, half its sum to infinity. And don't forget your sum to infinity is A divided by 1 minus R. You understand now? So it's equal to A divided by 1 minus R. Okay, if we simplify further, this is going to give me a plus ar squared is equal to a divided by 2 into 1 minus r. You understand now? So if I factor a out, this is 1 plus r squared is equal to a into 2 1 minus r. So you will see that a will cancel a cancels a. What do I have left? So then I have 1 plus r square is equal to 1 divided by 2 1 minus r. You understand now? So if you open the bracket, this one will give me 2 into 1 minus r into 1 plus r squared is equal to 1. Is that not so? So then if you still open the bracket, this is going to give me 2 minus 2r, 1 plus r squared is equal to 1. Okay, let us multiply through. So this is 2 plus 2r squared minus 2r squared minus 2r raised to power 3 is equal to what? Is equal to 1. You see that this guy cancel this guy cancel this guy. What do I have left? I have 2 minus 2r raised to power 3 is equal to 1. So then you have that minus 2r cube is equal to 1 minus 2 if you collect the like terms. So by collecting the like terms, you have this, which implies that r raised to power 3 is equal to minus 1 divided by minus 2. So then you have that your r is what? Cube root of 1 over 2. So you have r to be cube root of 1 divided by 2. Okay, now, how are you going to get that? Do you have such a number that when you multiply it by itself three times to give you 1 over 2? What is such a number? I don't think there is, or it will give us decimal. Let me see if we've not made a mistake. So you have something of this nature, 2r. Okay, if you cross multiply, you have 2 minus 2r, 2 plus 2r plus 2r square minus 2r minus 2r square minus 2r cube. So this guy cancel each other. So yeah, I don't think there is such number. Then it suffices to leave your answer like this. So that's that. That's how you can apply sum to infinity. If you understand, please don't forget to like, share, and subscribe. I will see you in the next video. Thank you.